Let's do section 4.3, mixed and entire radicals, example problems. Example 1, simplify each radical. So what we're going to do is we're going to take this entire radical and turn it into a mixed radical in simplest form. So what we do is we start off with our 63, square root of 63. We think to ourselves, what number, what perfect square can I divide 63 by? Well, I look over here at my perfect squares. I can divide 63 by 9. Now I have to check, is that the biggest perfect square that I can divide it by? I can't divide it by 16, 25, 36, 49, 64. None of those. 9 is the biggest. So I break this apart. 63 is equal to 9 times 6. Break it into two radicals. The square root of 9 times the square root of 6 equals 3 square root 6. There is my final answer. Now I can check that it was the biggest perfect square by trying to take this 6 and see if I can divide that by any perfect square. In other words, can I do this process again with 6? But when I look at my list of perfect squares over to the right, there is no perfect square that I can divide 6 by. So it is in simplest form. Right, now we're going to simplify the entire radical of the cube root of 108. Now, because this one's cube root, we have to look at our perfect cubes column. Our perfect cubes column is right here. So I think, can I divide 108 by 1? Yes. Can I divide it by 8? No. Can I divide 108 by 27? Surprisingly, yes, I can. 27 times 4 is equal to 108. So I'm going to rewrite this cube root as the cube root of 27 times 4. Then I break it apart to get the cube root of 27 times the cube root of 4. And that gets me, the cube root of 27 is 3, so it's 3 times the cube root of 4. Now I check again. The cube root of 4, can I divide that by any perfect cube numbers other than 1? And I cannot. So that is in simplest form. Last one we're going to look at now is the fourth root of 128. So now I need a list of the perfect quartics. So I've got a list drawn up over here. And there's very few options for 128. I have to check 1, 16, 81. I know 81 can't go into 128, so my only option is 16. So I have to see if I can divide 128 by 16. And in this case, I can. 16 times 8 is equal to 128. And 16 is a perfect quartic, so I separate it out. The fourth root of 16 times the fourth root of 8. And I'm going to get the fourth root of 16 is 2 times the fourth root of 8. Normally I don't write the multiplication sign in there, and I just write as 2 fourth root of 8. Now I can check to see, can 8 be divided by any fourth root? Well, my fourth roots are 1, 16, 81, 256, and 625, so no, they cannot. All right, we're going to continue on this process. Write each radical in simplest form if possible. And you should be able to get quick at this. So 16. 30. Can I divide 30 by any perfect square? Well, let's take a look at my perfect squares. I can divide it by 1, but that doesn't change anything. 4, nope. 9, nope. 16, nope. 25, nope. I cannot. I cannot rewrite it by any perfect square. Oh, excuse me, the application seems to have crashed, so I'm going to reboot it here. And 30 cannot be divided by any perfect square, so the square root of 30 is as simple as it comes. This is simplest form. I cannot divide 30 by any perfect square number. Let's take a look at the cube root of 32. And we look at 32. Can I divide 32 by any perfect cube? So 1 doesn't matter. I can divide it by 8. Can I divide it by a bigger one? Well, the next one is 27, and 27 is over half of 32, so we can't divide it by 27, and we don't need to go any farther. So I can break this apart. The cube root of 8 times 4. Then I break those two apart, the cube root of 8 times the cube root of 4, and I get 2 cube root 4. Now I'm going to check the fourth root of 48. So can I divide 48 by any perfect quartic? My only option is 16. Can I divide 48 by 16? And the answer to that is yes, I can. Because 16 times 3 is 48. So I rewrite this out. The fourth root of 16 times 3. Then I separate it. The fourth root of 16 times the fourth root of 3. The fourth root of 16 is 2, so this becomes 2 times the fourth root of 3. Right, so you should be able to take an entire radical and simplify it into a mixed radical. And of course, we should be able to go the other way. Write each mixed radical as an entire radical. So this one, we look at our index of r. In our first one, letter A, we look at the index of a radical, and the index of a radical is 2. So our 7 we have to change into a square root. Now, the square root of 49 is equal to 7. So we take our 7 and we change it to the square root of 49. Those two things are equal. In a math expression, we can replace one thing with something else so long as they're equal. And so the 7 becomes the square root of 49, and the square root of 3 remains the square root of 3. Then we can put these two guys together to get the square root of 49 times 3. And the square root, and 49 times 3 is equal to 147. And there's our entire radical. Let's look at B. Again, make sure to note the index. The index here is 3. That means we're dealing with cubes, cube roots, and cubes. So 2 is the cube root of 8. Right? Because 2 times 2 times 2 is 8. So the cube root of 8 is 2. So we take our 2 and we replace it with the cube root of 8. And then we're going to multiply that by the cube root of 4. Now we combine these two guys together, the cube root of 8 times 4, and we get the cube root of 32. There's our entire radical. Let's look at letter C. 2 times the fifth root of 3. All right, so make note of that index, fifth root. So the fifth root of what number will equal our 2? So this 2 becomes what? Well, it's going to be 2 to the power of 5. This is a simple way to figure out what this 2 becomes when we put it under a fifth root sign. So it becomes 2 to the power of 5. And then we're going to multiply that by the fifth root of 3. So this is going to be the fifth root of 2 to the power of 5 times 3. It's equal to the fifth root of, well, what is 2 to the power of 5? Well, count it up. 2, 4, 8, 16, 32. And that is equal to the fifth root of 96. All right, so you should be able to go back and forth from an entire radical into a mixed radical in simplest form, and from a mixed radical back into an entire radical. Follow the algorithm as provided here. If you have any questions, put them in the comments below or contact me directly.